Hello, am I audible and is my screen visible? Hello, can anyone please let me know if I am audible?
Yes, sir. Yes, sir.
And is my screen visible?
Yes, sir.
Okay, thank you. Good evening, everyone. Welcome to this NPTEL live session for the course Deep Learning IIT Ropar. My name is Learning-IIT. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my 6th live session. In this live session I will discuss some practice problems on week 6 topics. In week 6 autoencoders were covered. So we will discuss some questions on autoencoders, and if you have any questions or queries regarding week 6 topics, you can ask me during this session. Okay, we can start solving the practice problems first, and then if you have any other questions you can ask me. And this is the first question. Consider the following autoencoder. So this is the autoencoder. What is the dimension of the weight of the first hidden layer, W? So 4 options are given: D cross 1, N cross 1, D cross N, none of these. And hidden layer is calculated as H equals G of W xi plus B. So you have to find out the dimension of this W if we use this formula to compute the hidden layer. You can write your answers in the chat. The dimensions of the input xi, h are given. Xi belongs to r to the power n and h belongs to r to the power d. Vandana Mahajan says option C. Okay. Vandana says option B. Anyone else? Kajal Gurnani says option C. Anju Lakshmi says option C. So the correct answer is C, D cross N. So we are calculating H as G, which is some activation function, D xi plus B. So G, B, these are not important in this question. Important is we are calculating H by multiplying W with xi, and xi belongs to R to the power n. So basically xi is a n cross 1 vector or matrix. So if it is a n cross 1 vector or matrix, then this and the dimension of H is R to the power D. So H is D cross 1. To get D cross 1 from n cross 1 vector, we have to multiply it by a vector of matrix of D cross n. So this D cross n will be multiplied with the n cross 1 vector, so that we will get D cross 1 vector. So this is basically whether you understand the matrix multiplication compatibility or not. So if it is D cross n, then only you will be able to multiply it with the xi vector, which is n cross 1, and the output would be a vector of shape D cross 1. So correct answer is option C, D cross n. So is there any doubt in this question? So it's basically the shape of W would be the number of units in the next layer multiplied by number of units in the previous layer. So number of units in the next layer was D, and number of units in the previous layer was N. So it will become D cross N. Now the second question, based on the same autoencoder. Now you have to find out the shape of the hidden layer, shape of the weight W star, which is from the hidden layer to output layer. So in the previous question we found the shape of this W. Now you have to find out the shape of this W star. With the shape of xi hat, or the output is not given here, so you have to first find out the output of xi hat, then only you will be able to find out the shape of W star. Kajal says option A, which is N cross D. Vandana says option A. Anju Lakshmi also says option A. So correct answer is A, N cross D. So it is exactly same as the last question. So if so the shape of xi hat has to be n cross 1, so it has to belong to r to the power n, because in autoencoders number of units in the input layer and number of units in the output layer have to be same. So this xi hat, which is the output, is a n cross 1 vector or matrix. So there are d units here, there are n units in the output. So this has to be this matrix W star has to be n cross d, in with the shape n cross d, so that you can multiply this H, which is of shape d cross 1, and the output would be n cross 1. So answer is n cross d. Now question 3. In autoencoders, which of the following loss function is used? Squared error, cross entropy, none of the above. Vandana says option B, which is cross entropy. Vandana says both A and B. Kajal says both. Vandana says B for binary, A for real valued inputs. And Dr. R. Kotishwaran says option A, squared error. The correct answer should be A, squared error. I'm not sure whether cross entropy is used or not, but whatever I have studied, it's squared error is only used, whether it's binary or real valued. because the error function that is used is so because we want to reconstruct the input itself. So xij is the jth unit of the ith input, and this is the output for that corresponding unit. So the error is xij minus xij hat square, summation over j and I. So this is the error that is used. Cross entropy, I don't think it's used. I will check later, but I think for both binary and real valued inputs, squared error can be used for that. Now question.
But
Yes.
the video of the course says that both are used. As I said, for binary, it's cross entropy that is
Okay.
mentioned, and for real value, they said squared error.
Okay. Yeah, it is possible. I don't exactly remember that, but yeah, if it is mentioned in the course, then it might be correct. I will change that. I will check the lectures again, and I will change that. So most probably both of these two would be correct in that case. Yeah, thanks for the correction. I will check the video lectures again. Yeah, because even for binary the squared error would work, but most probably cross entropy would be better. I mean, even in case of binary, if we just find the difference between the input and the output by squared error, it should give a similar answer, but it is possible that cross entropy would do a better job in case of binary. Yeah, I will check that and correct it after the session. Question 4. Which autoencoder simply corrupts the input data using probabilistic process before feeding it into the neural networks? Sparse autoencoder, denoising autoencoder, contractive autoencoder. Kajal says option B, Vandana says option B. So denoising. Dr. R. Koteshwaran says option B. Anyone else? The correct answer is option B, denoising autoencoder. So it simply adds some noise into the data in form of probabilistic process that it flips the inputs before feeding it into the neural networks. So correct answer is option B, denoising autoencoder. Question 5. Which of the following autoencoder tries to ensure the neuron is inactive most of the time? There are 4 options: undercomplete autoencoder, overcomplete autoencoder, sparse autoencoder, and denoising autoencoder. Kajal says option C. Okay. Dr. R. Kotishwaran says option C. Vandana says option C. The correct answer is option C, sparse autoencoder. So in case of sparse autoencoders, sparse autoencoder tries to ensure that most of the neurons are inactive, that is most of the output of most of the neurons are 0, so that the hidden layers look very sparse. And most of the values in the hidden layers are zeros, and there are very few non-zero outputs or active neurons, and it helps in case the autoencoder simply tries to copy the input to the hidden layer and then to the output, which is possible in case of overfitting. In that case we will not get a very good representation in the hidden layers. So sparse autoencoders tries to reduce that effect, that most of the neurons are inactive in the hidden layers, so that it just can't copy the input to the hidden layer then to output. Question 6, statement is given that denoising autoencoders reduce the risk of overfitting. So whether it is true or false, you have to state. Vandana says option A, Dr. R. Kotishwaran says option A, Kajal says option A. Any other answers? The correct answer is option A, which is true. So dynamizing autoencoders, as we discussed in a previous question, that it adds noise values to the input, then that noisy input goes into the autoencoder or the neural network. So either in the form of probabilistic flip or in the form of Gaussian noise or normal distribution noise. So by adding that noise element into the input, it reduces the risk of overfitting, that it cannot simply copy the input to the output. So it has to reconstruct the input in some way, because the input has been input has become noisy, so it has to reconstruct the input. So some work to be done by the neural network. It can't just copy the input to the hidden layer and then to output. So it reduces the risk of overfitting by introducing noise into the input layer. So correct answer is true. Now question 7. If the dimension of the input layer in an overcomplete autoencoder is 5, what is the possible dimension of the hidden layer? So 4 options are there: 4, 2, 8, 0. Kajal says option C, Akila Ishwari says option C, Anju Lakshmi says option C, Vandana Mahajan says option C. So the correct answer is option C. So in overcomplete autoencoders, the input layer contains 5 units. So in overcomplete autoencoders, the number of units in the hidden layer will be more than the number of units in the input layer. So in input layer contains 5 units, so the hidden layer must contain more than 5 units. So out of these 4 options, only option C has more than 5 units. So option C, 8 is the correct answer. So in case of overcomplete autoencoders, number of units is more than the number of units in the input layer, and in the undercomplete autoencoder, number of units in the hidden layer is lesser than the number of units in the input layer. Now question 8. What is the primary objective of contractive autoencoders that distinguishes them from vanilla autoencoders? So option A says they learn a low dimensional representation of the input data. They maximize the reconstruction error between the input and the output. They minimize the reconstruction error between the input and the output, and they capture only the important variations or features in the data. They maximize the mutual information between input and the output. Kajal says option C. Vandana Mahajan says option C. Supriya Manna says option C. Dr. R. Koteshwaran says option C. The correct answer is option C. That they capture only the important variations or features in the data. So that is the primary advantage of contractive autoencoders, which distinguishes them from the vanilla autoencoders. So in contractive autoencoders, it introduces an extra aspect in the loss function in the form of the Jacobian of the hidden layer. So this is added to the loss function along with the squared error loss function. This extra term is also added into the loss function, and this is simply just the square of the derivative. So this is simply the sum of squares of all the derivative values of the hidden layer with respect to the input units. So by adding this term into the loss function, it only tries to extract the important features in the data, and the other features are given zero importance, so their parameter becomes 0, and only for the important features the parameter values become non-zero. So this way it extracts the only the important features in the data. Now question 9. Which of the following networks represents an autoencoder? So there are three options. Which neural network represents an autoencoder? Each of these neural networks contain three layers: input, hidden layer and output layer. Vandana says option C. Akila Iswari says option C. Anyone else? Kajal says option C. The correct answer is option C. So in autoencoders, number of units in the input layer should be same as number of units in the output layer. Number of units in the hidden layer might be lesser than the number of units in the input or more than that. That doesn't matter. But the number of units in the input and the output layer should be same. So that is only true for option C. Here we can see in the first option there are 3 units in the input, but there are 5 units in the output. Similarly here there are 3 and there are 2 in the output. So only in option C we can see that the number of units in the input layer and the output layer are same. So option C is the correct answer. So these were the questions that I wanted to discuss in this live session. Now if you have any other questions regarding any of the questions or any of the topics covered in week 6, you can ask me now. If there is no question, then we can end the live session now.
Last time, the last question of the matrix was left, and like
If you look at the
so we
other
had
option A is
discussed
correct.
it.
Oh yes. In that case, yeah, my answer was wrong there. So my mistake was that this was the formula. This question, right?
Yes.
Yeah. So instead of this 1 divided by n, so I was doing 1 divided by n minus 1. So this is also one form of covariance. So that's why the answer was wrong in my question. So it should have been 1 divided by n. So instead of 1 divided by, there were 3 points, 1 divided by 3, I was doing 1 divided by 2. So that's why I was getting a wrong answer. So the process would be exactly the same that I discussed, just that my this denominator was wrong in the answer.
Okay. Thank you.
Okay. Okay, thank you everyone. We will end this live session now, and we will meet again next week.
Thank you.
Thank you.